In this video, we're going to talk about how we're going to store our clients and our launchers on our site. So our continuous integration server, we're going to be using TeamCity for that, is going to need to upload both the client and the launchers to our site so that our launcher can download them, auto-update itself, and auto-update the client. But we're going to need some way to store that information on the database. We're going to need to know the latest version of the client and the latest version of the launcher and where they're stored on the website. So we will need some database action. However, I do want to differentiate between the client and the launcher as two separate classes, two separate entities, but they're so similar that we could very easily use inheritance and polymorphism in this case. So for example, we could have there we go. For example, we could have something like something like an upload. Let's call it an upload. How do you spell upload? U-P-L-O-A-D. Yeah, I can't spell. So I might have an upload-based entity, and I might have something like a timestamp, an ID, a version, and so on. And then we'll have a client upload that inherits from the upload entity, and then we'll have a launcher upload that inherits from the upload entity. So each one of these guys that we're looking at, client, launcher, and upload, are all individual entity classes. But we don't want to represent clients and launchers as two separate tables. That's fairly inefficient, and for our purposes doesn't make a whole lot of sense. Because our uploads, clients, and launchers are so related as far as the data that they expose and the behavior that we want to work with them as. That was a terribly constructed sentence, but I hope you understand what I mean. We want to be able to store this effectively on the database. So how do we do that? Well, there's a couple different ways we can go about using Entity Framework to store a hierarchy or a polymorphic data model on our database. And those separate methods, we have TPH, TPT, and TPC. TPH is table per hierarchy. And how do you spell hierarchy? It's a terrible word. Hierarchy. Yeah, I'm that embarrassingly bad at spelling. So we have table per hierarchy, and then TPT, which is table per type. And then we have table per concrete class. So table per hierarchy means that our entire class hierarchy is stored on a single table. So that means this hierarchy that we're looking at right here is stored on a single table. Let's call it the uploads table because that's the name of the base class. A table per hierarchy layout might look like this. We'll have our ID, which will be shared. Then we'll have our shared properties, like our timestamps, our version, and then we'll have a type. So it'll just have one table, and that one table will be able... That's a terrible box. That's a better box, I guess. This one table will contain the data for both our clients and our launchers. Now, the important thing about TPH is we need something called the discriminator. The discriminator is a special property or a column on the table per hierarchy table that describes which entity that particular row represents. Because in a table per hierarchy, we might have one row be a client and then the next row be a launcher. We need some way to differentiate between those rows because Entity Framework needs to know which of the two classes to instantiate. And that's done with the discriminator column, typically called type. We can instruct Entity Framework to understand different kinds of discriminator values and map them to particular classes or concrete classes in our class hierarchy. Now, there's a couple problems with TPH. One of them is that, of course, it violates normalized database form, but that's kind of irrelevant for our discussion. Another thing that happens with TPH is that any custom property that's on client or launcher, let's say, in this particular case, I can't honestly think of a property that would only be on one of these and not the other. Let's just use arbitrary names. Let's say client has prop 1 and launcher has prop 2. So prop 1 only exists on the client entities and prop 2 only exists on the launcher entities. Well, how is this handled? Well, unfortunately with TPH, that means that prop 1 and prop 2, so P1 and P2, have to exist on every single row. And it also means that any property that isn't shared between the different classes in the hierarchy has to be nullable in the database. Because, for example, we might have a client with an ID of 1, a timestamp of X, a version of 1, a type of client, and then it has a P1, and let's say the P1 is 5, and then it has a P2, but the P2 has to be null. And the P2 has to be null because this is a client row, and clients only have prop 1s and not prop 2s. And then the next row, we might have an ID of 2, a timestamp of Y, a version of 5, a type of launcher. I'll just do a capital L for launcher. The P1 will have to be null, and then the P2 might have a value. So one of the problems with TPH is going to be the existence of these nullable rows on every single record if we have a lot of properties that only exist on either the client or the launcher. So TPH is very efficient because, well, we only have one table to worry about. This gives us a couple of benefits. For example, not only does it give it the maintainability benefit of only having one table, but it also says that if we want to query for both clients and launchers at the same time, we have one table to query against. Let's say I want to get all the clients and all the launchers that have a timestamp of Z, right? Well, I can do that very easily by querying this one table. It's very efficient. And then when the record set gets loaded by Entity Framework, it uses the discriminator column to determine which of the two types to instantiate, meaning I'll get back an array of uploads. But it'll be polymorphic because some of the uploads, because obviously upload will be an abstract class, some of the objects will be clients and some of them will be launchers. So it's very efficient, it's very neat and tidy, but it breaks down when we have a lot of properties that are going to be shared or not shared. If we have a lot of properties on each individual concrete class that are not shared by their other class, that is when it starts to break down, especially because we can no longer mark these properties. Prop 2 and prop 1 can not physically be able to be null or not nullable. Prop 1 and prop 2 have to be nullable, as you see right here, because we need to be able to set them to null in the case that we used a different type. So that's TPH. TPH is I use it quite often. I like the cleanliness and the good performance in querying polymorphic data. And I often find that when I have closely related entities, see, I don't use inheritance a whole lot or very often myself, just as a matter of principle. When I do use inheritance, it typically is going to be something where I might only have one or two additional properties on my concrete types, making TPH a viable polymorphic strategy. Okay, so let's talk about TPT, table per type. I'm going to go ahead and do some quick Photoshop magic here, and by Photoshop magic, I'm just going to be moving those over there, and then I'm going to be moving this over here, just so I can, oh, come on, Photoshop. You're not going to do this to me. Here we go. Just to give myself some more room. Okay, so let's talk about TPT. TPT is table per type. Not surprisingly, there will be a table for every type in the hierarchy. Now, this also means the abstract types. So, for example, our upload, our client, and our launcher would all have their own tables. So, let's take a look at this. We will have an upload table, and the upload table will have all the upload properties on it. We'll have a client table, which will have all the client-specific properties on it, and then we'll have a launcher table. Now, from a DBA perspective, if you're really wanting to go with a third normal form database, this is your best bet because we have no repetition and we have no nullable types. Everything is normalized into this form. What do I mean by that? Well, our upload table is going to have our timestamps, our ID, and our version. Our client table is going to have an ID and a prop1. And our launcher table is going to have an ID and a prop2. That ID will be used to relate these different objects together. So from a DBA perspective, if you're really wanting to push a normalized form, this is the way to go. This makes the most sense from a DBA perspective because we have no repetition. It also works decently well with performance as long as you're only performing queries in one of two situations. As long as you're only pulling, well, that's not necessarily true because we still have to join. So I think I might have lied to you guys. I was thinking about TPC for a second. Every time you query on any of these objects, you're going to have to worry about joining. What does that mean? Well, let's imagine we want to query on the launcher. So select all from launcher. Well, we have a problem because what if we wanted to select all from launcher and then we want to where version is equal to 10? Well, how does this work? Launcher is this table right here, so that makes a whole lot of sense. But where is this version? Well, version is an inherited property that exists only on the base type. And in TPT, when we have a table per type, then version is going to be pulled from the upload table, which will require that we do a join. Now, relational databases are very, very good at doing joins. I mean, that's joining is really the one of the core capabilities of an RDBMS over, let's say, a NoSQL database. So joins are going to be fairly performant. They aren't something to be afraid of. They're not that complicated. But it still is an extra step. And I don't really like that, especially when we start getting really complicated hierarchies. And then let's say, for example, we wanted to query on all uploads. See, if we queried on all uploads on TPH, we would only perform one query with no joins, and then Entity Framework would know whether to instantiate a client or a launcher. If we perform a select query on upload, there are two possibilities, two things we could possibly do. A, we could query on the upload table directly and join on every single other table that exists in order to get this into one query. Of course, it'll be one query with X joins, where X is the amount of subclasses you have in your hierarchy. Alternatively, we could query on the upload table once, and then if the upload table had a discriminator type in it, we could query on the client and the launcher table subsequently, which would be ridiculously unperformant. So, as you see, TPT gets complicated. Now, fortunately, Entity Framework will handle all of the complexity for us in the way that it handles polymorphic entity relationships. Unfortunately, though, it still is complicated, and it will require additional thought process when working with it. But it is normalized, so I guess it'll make some DBAs somewhere happy, but I don't really care about making DBAs happy. So that's TPT, table per type. Now let's talk about TPC. TPC is table per concrete type. Well, a concrete type is a non-abstract type, and we have two of those in our hierarchy that we're looking at. We have client and launcher. The table per concrete type, or concrete class, is going to be something like this. We'll have a client table, and we'll have a launcher table. With no direct relationship between each other. Well, how does this work? Well, what happens is our properties that are shared between client and launcher are repeated between these two tables. So the client table will have a timestamps, a version, an ID, and a P1, and the launcher table will have an ID, a timestamps, a version, and a P2. So this is great. Table per concrete class I like more than TPT because it's less complicated, and it allows you to write concrete queries. If you're really ever only going to be querying a client or one of the concrete types, so you're only going to be querying client or you're only going to be querying for launcher, TPC makes a whole lot of sense because we never need to do an abstract query that queries for everything. If we do need to do an abstract query that queries for both clients and launchers, we simply do a union of these two tables. Now, a union isn't a particularly performant bit of SQL, but it is possible. And so in the rare case that we ever need to do a query for all things that are uploads, we can do so. So TPC is a nice trade-off, I guess you could say, between TPH and TPT. And it's, like I said, it's straightforward. In addition, the properties such as P1 and P2 that are different between our concrete types can be represented in a non-nullable way, which is really nice. All right, so those are our 3 strategies for handling a polymorphic relationship in Entity Framework. Again, our polymorphic relationship has one base class, 2 concrete classes that inherit from it. Both of them may or may not add additional properties. The 3 strategies that we have is TPH, or table per hierarchy, where we place the entire hierarchy on a flat denormalized table with a discriminator column called type. The next option is TPT, or table per type, where we separate out a table for every type so we don't repeat ourselves in our properties, but it requires some complex join logic in order to perform either concrete or polymorphic queries. Remember, TPH, we can perform concrete and polymorphic queries without any additional work. TPT, we have to do additional work in both cases. TPC, however, allows us to do non-polymorphic queries very simply, and it allows us to do polymorphic queries using a union instead of a join. Now, Entity Framework supports all 3 of these, and you can choose which one you want based off the situation. So I think that about wraps up our introduction to polymorphic relationships in Entity Framework. In the next video, we'll go ahead and set up our basic class hierarchy for our entities and map it to our database.